And I found this rather nice engraving, Otto C. Hilgenberg's Earth expansion globes, and these were constructed in 1933. He published his idea that in the distant past, for some unknown reason, the Earth was smaller, without ocean basins, remember. And that subsequently, the Earth expanded, an alternative to plate tectonics theory. So that was in 33. Okay. Now, Carey mentions in his book Theories of the Earth and the Universe, A History of Dogma in the Earth Sciences, how he first fitted these continents together in 1933. Again, we're back to this. But what he points out was that he was able to get a good fit, with a fairly good fit, as you can see, and you can see he's put the sort of various lines of measurement on to try and line it up. But he found that if he took into account the curvature of the Earth and fitted these together with an Earth of smaller radius, the fit was perfect, right? So these fitted even better on a smaller Earth than they do now. That's one of the key concepts in this. But this is never talked about. I only came across this concept in 2006. I'd never heard of the idea of expanding Earth until 2006. But it's been around, as you see, since 1933. Now, Professor S. Warren Carey in Continental Drift, as I say, he was a supporter of this. From Professor S. Warren Carey's book, Theories on Earth and Universe, this is from the same book again, Continental Drift, mental models bias our thinking, and continental drift hobbled at Wegener's concept in the English reading world from the outset. Wegener's word was Verschiebung, I think that's the way to pronounce it, which was correctly translated by Skirl as displacement. In other words, Wegener called it continental displacement, which is a much more scientific term than drift. All right? Drift was substituted by the detractors who thought this idea was plainly ridiculous, and as they were in the majority, the term gained currency, and saddled with that name, it was successfully slanted towards fantasy. All right? So the scientific community, having called it continental drift, so they didn't really take it very seriously. But for example, we've got people like is it Klaus Vogel or Kurt Vogel? I've got this on the next slide. He constructed this globe here, I think in the 60s or 70s, and he's got the smaller globe in the centre and then the glass sphere of the current globe to see how they map onto each other. Now, Warren Carey, his paper on continental drift was rejected when he wrote about it in 1957. But then later, obviously, it became what mainstream science taught and still teaches. So Warren Carey was essentially ahead of his time because he was onto continental drift whilst it was still regarded as a fantasy. But what I'm going to move on to now is Neil Adams, because if you've come across this on the internet, you won't have come across the science. This is another thing that's interesting to me. You'll have come across this guy, Neil Adams, and I've got a video by him.
This is our Earth. We will be going back in time and watching the tectonic movements of the last 200 million years. We will not be applying subduction, rotation of continental plates, reducing, enlarging, sinking, or rising of plates, and only such turning, rotation as is justified by magnetic striping, like the rotation of Spain, Great Britain, and Central America. This Earth globe will reduce in size to accommodate the reductions of all the oceanic plates as clearly indicated by the rainbow map of the United States Geological Survey. This being the case, it would be impossible for these upper continental plates to fit together perfectly, and yet they fit together perfectly. We invite close scrutiny. Yes, there has been some erosion, landslides, and such, but the overall result is insignificant. We have been asked to believe that the continental plates drift about willy-nilly, bumping and crashing into each other like bumper cars in a carnival. This does not happen. Continental plates never collide. They only move apart, ever. In actual fact, they don't really move at all. The rifts of the lower oceanic plates move apart as the Earth fills and grows. Do the upper tectonic plates match perfectly in the Pacific as well as the Atlantic? Yes. Do plants and trees match across the North Pole in type and kind? Yes. Why is this obvious conclusion not considered by the geological community? Perhaps it is because the ramifications are so staggering to all scientists across all the areas of science. The outer 2.5 miles thick of crust of an early Earth, though slowly stretching, was all one piece, until the rate of growth grew too fast for the brittle crust, and 180 million years ago it began to profoundly crack and spread deep over the entire planet. We are now going forward in time to show how the actual growth of the Earth took place. Antarctica, 200 million years ago, was subtropical. Africa, rising up on a smaller globe, was originally way down under the globe. In fact, for 100 million years, Africa was the South Pole. South America's tail went under and wrapped around the bottom of Africa, then incredibly joined coast with Antarctica. 65 million years ago and more, these continents were joined, and monotremes, like the duck-billed platypus, roamed from Australia, Antarctica, and across southern South America and up into Africa. The platypus. Dinosaurs roamed all over this world on the upper tectonic plate because there were no oceans, just shallow seas. Here today, Antarctica is frozen over, and Australia and surrounding islands are the remaining home of monotremes and marsupials. Do you see how broadly the Pacific Ocean is opening as compared to the Atlantic? This is exactly why the knee-jerk Pangea theory exists. The Pacific spread is too difficult to visualize because it's so big. The Atlantic spread is so obvious that a child can recognize it. But they are the same. On this small planet were the shallow seas that covered 2/3 of the continental plates and have since completely drained off into the newly rifted open deep oceans. These shallow seas on the continental plates hold every scrap of evidence ever discovered of ancient sea life of the Earth. Those shallow seas are completely gone now, completely drained off into the new rifted open deep oceans, lowering the actual sea level by 1/2 mile. Is this possible? The oceans have absolutely nothing to do with tectonic spreading, except that they cool the thickening mantle. Tectonic spreading, even according to the most conservative scientists, has created 2/3 of the Earth's surface in the last 200 million years. And therefore, the same must be true on all planets. Now I'm going to run the Atlantic and Pacific without rotating the planet. Honestly, there's no tricks here. I did nothing while the other side was turned away. Please examine this carefully. The outer, upper tectonic plates, the land fits together like a pulled-apart puzzle. No exceptions. There is simply no doubt of any sort that these land masses fit perfectly on a smaller planet. All our natural history tells us this. No ancient oceans existed. Now drained shallow seas hold the only undersea history that exists on Earth. Antarctica was subtropical. There were no frozen poles before 60 million years ago. If Earth was always the size it is today, we've got a problem, because 2/3 of the upper tectonic plate is missing. If subduction existed, and it doesn't, it simply cannot and does not explain anything at all. The evidence is overwhelming. It simply needed collecting and demonstrating. The Earth grew. No Pangea, no Gondwana, Laurasia, or Tethys Sea. No meteorite knocked off the dinosaurs, no vacuum in space, no Big Bang. If what you see before your eyes right here is true, the Emperor has no clothes, and everything in science must change.
So I'll go on to the next bit. He also has got a clip about Mars as well. The same sort of thing seems to have gone on Mars, which again, sort of time's getting on, so I'm not going to play that. But guess what? One of the most prestigious science journals, Nature, Secular variation of Earth's gravitational harmonic J2 coefficient from Lagos and non-tidal acceleration of Earth rotation. It's clear as a bell, that, right? Our planet's waistline is mysteriously increasing, it says in little tiny letters that you probably can't read. And that was published in 2002. But what they basically said at that point was, well, it's pretty small, it's probably just instrument error, so, you know, even though we've taken all these measurements, it's probably wrong, so we'll just ignore it. Now, what I found is that this is becoming more people are getting on board with expanding Earth now. There's even a conference in October last year, 2011, 9th of October. And so it is getting more popular, and they had a lot of research published there. I haven't been through the papers, but I'm told they're going to publish a book from this. But one of the guys that spoke there, it was quite nice, because when I did this talk in Lytham St Anne's about a month ago, in fact it was less than a month ago, the chap who wrote this book, Stephen Hurrell, he created these animations over quite a long period of time actually, and this is what he did. Essentially did the same thing but independently of Neil Adams. Neil Adams is a comic artist, he's not a scientist. This guy's an engineer, Stephen Hurrell, and he basically resized the Earth by deleting the ocean floor. So remember those blood red lines that you saw on that, you know, sort of oval shaped globe that I showed? He took out all those lines and then shrank the size of what was left, and all the continents fit together. That's exactly what Neil Adams did. But the other main guy that I've came across, and I heard of Neil Adams in 2006, I didn't hear of James Maxlow until 2012 when I was doing the research. He's the scientist, right? And he's written a whole PhD on this. I only discovered this recently. And he even did quite an impressive presentation, which I've got on DVD at the back there, in 2005 at Nexus. So if anyone wants a copy of that, I've got it on DVD at the back there. He constructed a whole range of globes, as you can see here, with different, you know, with the varying sizes, going back to about 200 million years ago. And in his PhD research, Maxlow has considered evidence of ancient climate, that's coal deposits and fossils, ancient magnetic poles, he located where the ancient magnetic poles were at each of the stages, ancient geography, in other words how everything fits together, ancient biogeography such as coral reefs and where they were located, because they can only fall within 30 degrees of the poles because of the temperature. And it was recently stated, I think in that Nature article, that the measurement showed an expansion rate of 18 millimetres a year. All right? Maxlow had independently calculated a rate of 22 millimetres a year. Isn't that interesting? He concludes that the Earth's mass, the amount of material of which it is made, has also increased, which is very difficult to explain. And that's why people don't go for this, because we don't know where the extra mass can have come from. So this is some of James Maxlow's reconstructions of the earlier Earth based on the geological evidence. You can see he's mapped it all out. I've got another video which will show you part of this. It's very, very detailed. It's not like Neil Adams. You know, Neil Adams, that thing is very, very good for illustrating it. Or you can really see that those things really do fit together when you shrink them down. But James Maxlow has proved it from the geology. And this is one example where he's mapped the magnetic South Pole, and he's actually looked, based on the magnetisation of where the rock is, as to where the magnetic South Pole was, and matched that up, for example, where the equator was then 90 degrees from the pole, and that's where he found the evidence for coral reefs, or within 30 degrees of that. So he's matched it all up, and these are the continent outlines coming now. And he's got about 15 of these videos where he views it from different angles: North Pole, South Pole, equator, and so on. And these are these ocean ridges again. And that's going backwards again. And he projected it into the future as well, 5 million years. So those colours are basically, in a nutshell, those are the science. The coloration is based on the geology and so on that he was looking at. So he's proved it from a geological state. Now, if you take this to a geography teacher or to a geologist at a university or whatever, they'll say, oh, it's bollocks. It's subduction, as the gentleman at the back was saying. You'll hear many geologists and scientists pronouncing that subduction is the process by which plate material is destroyed by going under newer ocean plate, Commonly seen in textbooks are diagrams like these, where you've got the oceanic plate going under the continental plate, and therefore the older continental plate is destroyed. That's why we don't see evidence of it, according to the textbooks. When two oceanic plates collide, the younger of the two plates, because it is less dense, will ride over the edge of the older plate. Oceanic plates grow more dense as they cool and move further away from the mid-ocean ridge, according to what they've said. The older, heavier plate bends and plunges steeply through the asthenosphere, and descending into the Earth, it forms a trench that can be as much as 70 miles wide and more than 1,000 miles long and several miles deep. The Marianas Trench, where the enormous Pacific plate is descending under the leading edge of the Eurasian plate, is the deepest seafloor in the world. It curves northward near the island of Guam, and its bottom lies close to 36,000 feet below the surface of the ocean. But some people dispute the evidence of what is happening at places like the Mariana Trench, which is true, and they don't agree that it's subduction. But why, again, is the oldest ocean floor only 180 million years? Well, they'll say it's all disappeared underneath it. But they don't actually use that magnetic data in their studies now to prove it. And this is just a picture of where from Google Earth of where the Mariana Trench is. So all these volcanic islands are meant to be a result of the subduction that's going on underneath them and all this volcanic activity that's around here. But you could just as equally argue that that also is coming from states of expansion, because you're getting stuff underneath there which is still active. So, as previously mentioned, subduction crust beneath continents is an artifact of the basic plate tectonic requirement for a static radius Earth. To maintain a plate tectonic static radius Earth, the new oceanic crusts accumulating along the mid-ocean spreading ridges must be continuously disposed of elsewhere, displacing and recycling pre-existing crusts into the mantle by subduction. Modern planetary studies have shown this process to be unique to planet Earth, and hence without subduction, plate tectonics cannot exist. So there's no plate tectonics measured on Mars, for example, as far as no evidence for that on Mars, for example. On an expansion tectonic subduction, Earth subduction with between 5,000 and 15,000 kilometres of Pacific oceanic crust between North America, for instance, is unnecessary. All subduction-related observational data is simply record the crustal interaction between adjoining thick continental crusts and relatively thin oceanic crusts during ongoing change of surface curvature. That's the key thing. As the Earth radius increases with time, the surface curvature of the Earth flattens, giving rise to a crustal interaction of jostling of plates along their margins as they stretch and distort during Earth-induced flattening. And you're going to see what he means by that exactly in the next video. So this is what he means by the Earth expanding and the crustal changes because of that.
This next slide is an introduction to the next phase of this presentation. What happens to the continental crust and in part the oceanic crust when we increase Earth radius? And this is alluding to a mechanism for mountain building and seismic activity and volcanic activity, etc. Shown here is a cross-section of a primitive Earth, the Permian-Pangean Earth, at 50% of the present Earth radius, and the present-day Earth. I've also shown a little fragment of a primitive crust, just one small fragment, and this is about 5,000 kilometres diameter, about the size of the present-day European continent. I've omitted, for clarity, I've omitted the rest of the crust. So what happens when we increase radius is we get a progressive, we'll just see if that animation works, yep, we just get a progressive flattening of that surface curvature. Now this is a very important point to accept, is that you get a flattening of this surface curvature and also an extension of that component, that radial component through here, sorry, the chord length through here. This doesn't happen all at once. It happens over a projected period of time, over that full period of time. The elevation, the difference in elevation we're talking about is around about 580 kilometres of this material must collapse, progressively collapse. So as the Earth progressively increases in radius, you're getting first off you're getting a slight super elevation of the continental material as you get both sets of both crusts joined together, you get a super elevation in the continents, hence the continental crust. The primitive continent, supercontinents, and within the adjoining areas, the areas of the continental seas, the depressed areas. As you then progressively flatten that crust, you get compression within those continental sea areas, compression, folding of these soft sediments, any jostling, you get mountain building and volcanic activity, and also introduction of metals and granites and volcanic rocks. I guess this is what I find throughout history, is that this is generally pulsed. You get super elevation, collapse, and also erosion of that crust, the elevated crust, and weakening of that central area, and collapse again, compression to form your mountain belts, extension, basin forming, sediments, new sediments, compression to form new mountains, and so on. We'll just hone in a little bit closer to, and this is a schematic representation of what happens to the crust itself. Now, what's shown here is the continental crust, about 30 to 70, 80 kilometres thick, overlying the mantle, which is hot, plastic, superheated, and the starting off of a shallow continental sedimentary basin and overlain by water, or by shallow seas. As you get radial increase, this is transferred to the crust as crustal extension. So you can imagine this as being, say, a piece of plasticine or a toffee or something. You stretch that over a very long period of time, you get stretching and elongation. And a very good example of the rocks that would form in here down in the foyer. If you go down the foyer, look at the floor, look out in the mall there. These gneissic rocks have a very stretched, elongate, attenuated fabric. This is typical of this environment. If you continue to stretch that crust, you then start getting faulting, what we call listric faulting along these margins. And a classic example of this is the Red Sea between Africa and Arabia, where the margins of this sea are fault-bound, these classic listric faults. Continuing on with that extension process, we then get into a continental scale where we get a breakup of this and fragmentation to form the modern continents and the modern oceans, the modern ocean basins, and then migration. That's a little animal.
So you can see there how he illustrates how that's how you get, like, say, for example, the Greek islands all breaking up as the crust expands. Makes perfect sense to me. Perfect sense. Now, expanding Earth, larger life. Walking with dinosaurs. It's often been a mystery and a source of fascination and wonder as to why the dinosaurs grew to enormous size. Some have asked, how could their bones have supported their own weight? It's a big problem. And this is a page I found about this. Now, it used to be, I think when I was a kid, this animal was called the Brontosaurus, I think, and they've renamed it for some mysterious reason to a Brachiosaurus, right? So the Brachiosaurus is a bit of a mystery because they said it had a long neck so it could reach up, you know, and feed off these tall trees and whatnot. But if you look at its physiology based on the fossil evidence, its heart couldn't have been big enough to pump the blood up to the top of its neck. So as soon as it raised its neck up, it would have passed out. Not only that, the skeleton would have collapsed under its own weight. It's a bit of a problem. And again, somebody's calculated these figures. Again, I'm not going to read all these out, but just to show you, you can look at the front leg circumference in millimetres, you can look at the animal's weight, and then you can work out the stress, right? And if you look at the dinosaurs, these are just for modern animals, cloud leopard and elephant goes up to 17.1, that's got a stress factor of 17.1 on its legs. But for dinosaurs, you would go beyond the stress that bone could stand for some of the big ones. Now, in his book, Dinosaurs and the Expanding Earth, which I got for about £6 off Amazon, I read this one, very easy read. Stephen Hurrell presents some basic information and evidence along with some calculations illustrating that the most likely explanation for the enormous size of the dinosaurs and other life is, guess what? a reduced force of gravity at the Earth's surface. Why would that be? Because the Earth was smaller then, folks. Less mass. And at that, of course, you can't have that. That's science heresy. It's just not possible. So people don't just ignore it. But again, if you do the calculations, like in that table, as Stephen Hurrell did, you show the simple problem how weight increases with volume. So an animal that has double a given length would have 8 times the volume of body mass. And the stress on the bones would be twice as great. Right? So our bones, for example, are only designed to hold a certain weight. It becomes a much bigger problem with dinosaurs. And of course, we've got to remember that it wasn't just like T-Rex and Brachiosaurus. They've argued with Brachiosaurus, for example, that because it was so big and it couldn't have supported its own weight, it must have lived in swamp regions all the time. And half its body was in water. And they've got away with it by doing that. But you do have a bit of a problem with Argentavis, I think this is called. Argentavis. This is a bloke here, if you can see it. This is the size of the bird. And also there's another one called Quetzalcoatlus. These were definitely birds. From the fossil record, you can see they were birds with, wing structures, like bones for wings. Yet, if you work out their weight and work out the aerodynamics, they couldn't have flown. So that bird either evolved to fly, or it evolved like wing-like structures just to flap around and do nothing. So that's a bit of a problem for the people who say that gravity was the same, because these birds couldn't have flown, even though they were, prehistoric birds, or flying lizards of sorts. That one might be a lizard and that one might be a bird. I'm not an expert on bloody fossils as well, but this is basically if you do the calculations and work out these things that were too heavy to fly, based on the wing surface areas and so on. And of course, it wasn't just big dinosaurs. We had this. I mean, I was watching Springwatch last week, and they talked about the prehistoric dragonflies. And this one is about a metre long. How did the insects get so big? And they claim that they were able to grow bigger because there was more oxygen in the atmosphere. That's what they said on Springwatch. But how did they fly, though? Because this has a skeleton made of, I think, of chitin or something that this skeleton made of. It's not bone. How did the skeleton support the weight of the wings for it to fly? And this millipede, how did it grow? I think it was 2 metres long. That's 2.5 feet, so that was almost a metre wingspan, that dragonfly. And this was 2 metres long, this Arthropleura, the biggest land arthropod known to man. How did it get so big? So I present to you the Earth has been expanding, and it's still expanding. James Maxlow says it's been expanding exponentially. It started off slowly at first, then it's increased mainly from about 180 million years ago. Some point then caused it to start expanding exponentially. It's still going. But the problem is, why people don't accept it is there's no known cause. They can say, well, what can cause it to expand? One example is meteoric and asteroid accretion. This is what's in Stephen Hurrell's book. This is the one that he argues. He basically says that, there's a figure I think this figure changes, but there's 7 tons of meteor dust falls on the Earth every day. Just, bits of dust, space dust, meteorites that break up in orbit and stuff like that. The figure ranges out, the figure I heard was 7 tons, but some people say it's 100 tons a day. Obviously, when that mass comes down to Earth, it isn't going to go anywhere, is it? It's going to stay on the Earth. So over millions and millions of years, that is going to add up and add up and add up and add up and add up. And you're not really going to get that many events that happen on the Earth to blast that matter off back into space again. Or at least not very much of it. But that doesn't explain why the ocean floor is expanding. And you've got this apparent contradiction there, because it doesn't really seem to explain that very well. Has the Earth been a constant mass? And then some people say the Earth has been constant mass, but you've had things like the gravitation constant G has changed. This is the thing that comes into Newton's equation. And this is, they say that this may not have been constant over millions of years. It may have reduced. But Carey rejected this proposal